It's spring at the Lincoln School in Brookline, Massachusetts. Malia Scott's second grade class begins a new lesson, exploring strategies for subtraction.
We have been working on addition and subtraction really since the beginning of the year. I'm going to ask for a volunteer who would like to read this first problem right here. Jack?
Last week, the second graders in Miss Scott's class planted 56 bean seeds. On Tuesday, the class counted 27 beans sprouting. How many plants had not sprouted yet?
What's a bean sprout? What does it mean when they're saying beans are sprouting? Yes?
When the beans starts to pop out of the dirt and it begins to grow its leaves and all.
What is the difference between the root and the sprout? Kurt?
The root goes down and the sprout goes up.
Excellent. So the root... They had a familiar context that they were working with the beans that we've been studying in our life cycle unit. As they worked through this problem, they were able to constantly refer back to the problem itself to help them to get understanding of what it was they were trying to figure out. Look at the numbers that are involved in this problem. Think about what's happening in this problem. And tell me what you think would be a reasonable estimate. Maria?
56. 56 minus 20. I think it's going to be around 30.
Okay.
I think it's going to be around 39.
Okay.
I think it's also going to be around 39.
Okay, tell me why.
Because if you took away 20 from 50, whoa, actually I think it's around 30.
Ah, tell me why.
Because 50 take away 20 equals 30.
Okay, I want you to be keeping those estimates in your head as we're going back and problem solving. That will help you to figure out whether or not you come up with a reasonable answer, okay? I'm going to give you one sheet for you and your partner. So you're going to need to work together to come up with strategies that will work for that problem. So we'll ask you to come up with 2 strategies for each problem. How about we'll have one person record one strategy, one person record the other. If you have questions, what I'm going to ask you to do is first talk to your partner and see if you can figure out that problem together. Okay? I really build in from day one the expectation that they will share their thinking and communicate their understanding. And along the way, I really try to build in as many supports as possible to help them to feel comfortable and confident. All right, you want to explain to me what's happened so far?
Well, we already did this one.
Okay, can you read to me what your strategy was for that?
I counted back on my fingers and he used the 100 board.
Okay, so you've told me what strategy you used, but I don't know how you used that strategy. If you weren't here and I was looking at your piece of paper, then I should be able to understand exactly how you thought about that problem and how you solved that problem. So let's think about a way that you can make it a little bit clearer here. Chris, which strategy did you use?
I used the...
You used the hundreds board?
Yeah.
Okay, so tell you what. Why don't you show us what you did, and then we can think about a way of recording that strategy here.
Well, on this one, I started on 56.
Hey, that's a great place to start. Jack, why don't you write that down? One student was working with the hundreds board. He was able to start at 56, so he was able to conserve that number in his head as a whole. But then he counted backwards by ones. And he was really looking at those numbers as individual units. He wasn't in any way chunking those numbers together, which is ideally where I would like to bring him to help him to reach his answer more efficiently. You know what? Can I ask you to read that back to Chris? Chris, I want you to listen carefully and see if there's anything that he left out there.
I started on 56 and counted back on the 100s board. I counted 27 back and landed on 29.
What does that 29 stand for, Chris? the 56 was how many beans we planted, right?
Yeah.
And then the 27,
Is how many sprouted?
right? And so what was that 29?
So there were 29 still under the ground.
Exactly, exactly. Okay, Jack, you ready to switch? And explain your strategy to Chris? Write one more for each other. I'm going to ask you three to...
The next day, Wednesday, the class counted again and found a total of 38 bean plants sprouting. How many plants had not sprouted yet? I'm doing 38 plus how many equals 56. So I borrow from here and make this a 40, and this is 16, and then 8 plus 8 equals 16. Why don't you write 40 above here? And then 30 plus 10 equals 40. And then 10 plus 8 equals 18.
I noticed that you're using the same class now. Melina, can I ask you to do that? And I think there's a good space for you right over here to do that. Okay, so can you read the question to us first?
Well, the next day, Wednesday, the class counted again and found a total of 38 bean plants sprouting. How many plants had not sprouted yet? Well, we had to take away 38 away from 56.
Why? Tell us where you had to get those numbers from.
Well,
Where did you get that 56?
from the first problem last week when they planted 56.
So you had to look back to the first problem to find out altogether how many they had planted.
And then it said they had found 38 that had sprouted.
So what are you trying to find out in this problem?
Well, you have to find out how many plants had not sprouted out of 56 of 38. So, 56 take away 38 equals, break a 38 up into
A nice
30
big voice,
and an
Melina.
8, and then 50 take away 30 equals 20, and 20 take away 8 equals 18.
Is that not looking right to you? I saw you make a funny face when you were looking at that problem.
Well, it doesn't make sense because it's 56 take away 38, but...
So why don't you walk us through the steps, okay? Where did you get the 50 and the 30 from?
Well, the 50 from the 56 and the 30 from the 38.
Okay, then what did you do?
But, wait a minute. It was 56 take away 30 equals 26.
Oh, so you decided not to break the 56 up?
Yeah.
Okay.
But then, see, it wasn't really my strategy, so I don't know what I did with the 6 or anything. I think Kate's gonna come up and have to help.
That's fine. If you'd like Kate to come up here and help you out, that's fine. Kate, you want to come on up here and help share this strategy?
I didn't know it.
So then what did you decide to do first, Kate?
I broke up the 30 and the 8. I broke up the 38 into a 30 and an 8.
Okay.
And I minus the 56, take away 30, equals 26.
Can I ask you a question? I've seen other kids here today break that 56 up into smaller numbers so that it's a 50 and a 6. But you kept that whole. Why did you decide to do that?
Because it was easier for me to think about it.
Okay.
And then 26.
Okay, so can we go back to this one for just a second? So
56 take away 30 equals 26. 26 take away 8 equals,
It says 18 here.
18 still? Because
Yeah, 18.
thanks, Kate. That helps to sort of clarify it. So what did we learn about the plants? How many had grown on Tuesday? Maria?
27.
So 27 of them had grown by Tuesday. So how do we use that information to figure out how many had not?
It was 29 then.
This is what I want to make sure that we go back and get clear in our heads. Because right now we've been working on so much problem solving that I want to make sure that we've got it clear in our heads what these numbers stand for. So on Tuesday, how many plants had sprouted? Daniel?
27.
And how many had not sprouted? Maria?
29.
Okay, so let's go over to Wednesday. This approach for teaching subtraction has really provided me with wonderful insight into my students' learning and given my students an opportunity to really work their way through their understanding of this very, very complex function. They're given an opportunity to share their strategies, which helps me as a teacher to get a stronger understanding of what they're thinking and where their understanding is, and start to help me to plan where I want to take them next.
How did students differ in their approach to solving the problems? How does context add to student understanding? Identify examples of effective teacher intervention in the lesson.